So today we're going to be talking about giving you an introduction to FileCatalyst and talking about how FileCatalyst can replace, how you can replace FTP with FileCatalyst and the benefits this can bring to your organization and to your workflow. My name is John Tkachevsky. I'm the president and co-founder of Unlimitech, the makers of the FileCatalyst products. We've been working with the FileCatalyst product line since 2006. It has several very big features developed to help moving very big amount of files or big data over wide area network. So this was really the premise of the product, that we wanted to add acceleration, automation, and all the features that you might need, a large business might need to move big data around the world. We do have a very nice blog, so check out our blog after the webinar. We have quite a few nice technical articles in there, as well as our take on some of the industry trade shows that we attend regularly. We probably do over 10 trade shows per year around the world, where we talk about our technology and introduce introduce the technology to different different verticals as well as different markets. So with quickly, I'm not going to go with very big detail here, but I just want to give you what is FileCatalyst. So first of all, it is an acceleration tool. So moving files at line speed. When you transfer files with FileCatalyst, you can always achieve the maximum available bandwidth to you, regardless of the network conditions. Our algorithm is patented for moving these files. We do use UDP to move it. I will get into that in a minute. We can achieve transfer rates up to 10 gigabits with our algorithm, even in harsh network conditions, meaning when you have latency and severe latency and packet loss. We can do this on commodity hardware. There's no need to buy any specialized CPUs or hard drives to do it. We're not affected by latency and packet loss, as I already mentioned. And we also now have an integration to storage solutions like Amazon S3, for example. If you want to move your content to S3 or from S3, you can use FileCatalyst for that. By the way, if you have any questions during my webinar, feel free to ask them in the questions in the questions box on the GoToWebinar interface, and I will go through them at the end of my presentation. So first, the biggest question is like why we're faster than FTP or SFTP or any other protocol out there. Well, if you look at the internet today, and you look at all the file transfer protocols available to you, for example, FTP, FTPS, SFTP, Windows file sharing, like a Samba, for example, all HTTP, all these protocols use TCP as the underlying protocol for moving files. TCP has been around since the 70s. It's a very reliable protocol. In fact, the internet would not exist without TCP today. Unfortunately, TCP has not been designed to move big data. And the reason why is that TCP is a very serial process, meaning that when I take a little packet of data from my source to destination, I'll build a packet of data and I'll move it over to the destination. Once the destination or the receiver gets this information, they'll confirm that, acknowledge it, and then I can go back and get the next packet of data and send it. And here's kind of, you can see this on my diagram, that you see there's always one packet of data on its way from the source to the destination, which causes quite a bit of delays when you have latency on the wide area network. Latency is really the round trip time that it takes for a packet of data to go from one end to the other. You can very easily see what the latency is for on your network by just doing a ping test between one box and another box where you're doing your FTP, and then you can evaluate what latency, what type of latencies you're dealing with. Now, the higher this latency and the bigger the pipe, the less data you can get through that pipe. So TCP once again has not been optimized for moving files over long haul. Another thing that TCP does with packet loss, and that's really more on a satellite or wireless connectivity. If TCP detects any packet loss, it cuts that packet of data that it sends in half, and then starts the process all over again. So you can see very quickly how much it slows down. So here's how we work. We've built our protocol from the ground up using UDP. We move files over the UDP, and then all the predictability of TCP is built into our applications. So instead of taking one packet of data, we actually move several at the same time, which means that there's a lot more data in transit, and therefore the files get there faster. It's the ability to fully utilize the link. Another advantage that you have with our protocol is that now you can specify with exact rates for your transfer. So, for example, if a transfer you're dealing with 3 file transfers at the same time, and one is more important than the others, you can tell the other ones to slow down, and that one that is important to speed up. Another thing that we've also built in is a congestion control. So, UDP transfers are great, but if you're sending at rate that is too fast that your actual physical link can handle, well, then it's going to cause all kinds of problems. So we've also built into our protocol congestion control. And once again, this is all patented, and it's been in use by media industry and several other verticals for almost 10 years now. So this is kind of shows you that the full utilization of the pipe. There's no acknowledgements happening. The only time we acknowledge in our protocol if there's an exception. So if something happens, so a packet goes missing, or we're sending too fast, this is where the acknowledgement will come in, and this allows us to save quite a bit of time on the transfer. So what type of transfer speeds are we looking on improvements here? So here's an example for LA to New York transfer with 70 milliseconds latency. This is a 10 gig file that we're going to be sending. With FTP, this is going to take just over 5 hours to transfer. With us, it's going to take a minute and a half. Yes, it's a quite a dramatic improvement, but this is the type of what latency will do to any TCP traffic. Once again, there's an example here for LA to Rio, transferring a file, also the same 10 gig file over 1 gig line. Now FTP will take 15 hours, and we're still under a minute and a half. So as you can see, we're not affected at all by this RTT time, and so on. The interesting thing is that if we gave you an example where RTT is 0, so meaning that we have 2 computers side by side connected with, let's say, a fiber connection just to make sure everything's super fast, then FTP would give you a very comparable speed to FileCatalyst, which would be, roughly a minute 24, so a minute and a half. So you can see that in a perfect world where our technology is not needed, but unfortunately we don't live in a perfect world, and speed of light is what it is. It cannot go faster. Therefore, our networks are going to be going at the speed that they are going today. Yes, you can shave off a few milliseconds of your RTT if you do good routing, but this is not going to give you the dramatic improvement you can see here on my example. On the 10 gig pipes, now this is much faster lines. Now you can see same scenario, 70 milliseconds and 10 gig file. Well, it still takes 5 hours, 5.5 hours with FTP, and with us it's now 8.4 seconds. Why? Because we're able to fully utilize that link. That means the 10 gig link will have the data in that link will be fully saturated. You'll be able to get the full bandwidth speed. And with Rio, once again, this improvement is dramatic. So you can see the improvement is quite substantial. It's something that is very is very this improvement is very needed, is very required by a lot of businesses that are working, internationally, and wherever you need to move push data, or let's say you have a certain amount of time, you need to push certain amount of data, you can now consider using FileCatalyst instead of, for example, shipping hard drives or shipping tapes, because this is something you can do over the network. So how is everything deployed with FileCatalyst? So we have three real product lines. We have FileCatalyst Direct, Workflow, and Central. Here's the average scenario of how FileCatalyst Direct solution is usually deployed at our clients. So we'll start here. We'll start with your storage. So you're going to have your storage where all your data resides in your office. We'll give you a server application. This is all software. We're not going to give you any hardware here. So it's just going to be a software that you install on your own virtual. You can install it on a virtualized box or a hardware box, and that box will have to be connected over local area network to your SAN on your NAS, so it has quick, rapid access to the files. Additionally, you can now attach FileCatalyst server to a cloud storage, for example, S3. If you attach it to S3, of course, then the FileCatalyst server would have to be deployed on, let's say, an EC2 instance on Amazon, so it has, once again, that local access to S3. You will have your internet connection. So once again, this could be fiber, DSL, cable, VPN, 3G, 4G, LTE, satellite, microwave link, any kind of IP network that you have that you're currently using. And on the other hand side, you're going to have different client applications connecting to the FileCatalyst server. So we offer 5 different ones. The reason we offer 5 is that there's different use cases. So let's talk about the simplest one to understand, the Express application. So the Express application looks like FileZilla pretty much. It's a 2-pane window where on the left-hand side you have your local files, on the right-hand side you have your remote files. You browse to the appropriate folder and you transfer files by clicking on an arrow from left to right or right to left. It's up to you. So this is something that's the Express application. Very simple to set up, very simple to understand, but it's not automated. It's something that a user has to manually do, log in and do it manually and watch that perhaps that progress bar. Another application that is much more flexible and popular in our deployments is our hot folder. So hot folder is an automation tool, and as well it also has the Express built in, so you don't really need 2 applications at the point, because you can easily quickly connect with hot folder and do the manual transfers, or you can set up a fully automated transfers as well. So imagine hot folder is going to be monitoring files on my storage here, and let's say every hour it's going to wake up and grab any new files and automatically start downloading to a predefined location on the hot folder. It's fully automated. I don't have to do anything here as the end user. Files just appear on my desktop. And vice versa. I could drop files into a folder on my desktop here, and hot folder could, let's say, wake up every hour, half an hour, 5 minutes, whatever schedule you want, and start uploading files to your storage. The logic where the files go and the scheduling and the bandwidth, everything can be configured and automated. So all of this is up to you as the administrator of the server to configure that. If the user from hot folder X connects, take him to a folder Y on my attached storage. Once again, you don't have to use attached storage. You can use local storage as well. But you can use any local paths or any UNC paths to your storage. We also have ability to connect web applications. So imagine a user, you put on your website a link, click here to send us files, and now a user can send files directly from your website to your storage, or vice versa, can download from your storage directly to the web. This will allow you to this will allow the user to not have any client applications installed. They can just go through the web and do it. There's a small plugin that they have to first download. They'll be prompted to download before the first time ever log into the system, and then they'll be able to utilize UDP from a web browser. APIs, well, we have APIs for Java, C++, .NET. We have SOAP, REST APIs. So options are quite big for integration here. All our APIs are bidirectional, meaning that they can upload to storage or download from storage, and then you can plug in. Also, the command line falls under our API bucket. And mobile apps, if you go to iTunes or Google Play on your phone and search for FileCatalyst, you'll find our app. You can download it. You can punch in this app the host name of your server, username and password, and then you're off to the races, and you can upload from your mobile device to your FileCatalyst server and to your storage. So here's some of the use cases. So one of the biggest use cases we've seen is transfer, distribution, and transfer of large files domestically and globally. So you imagine you have a central office with several satellite offices, and you need to, for example, have a synchronized folder with each all these locations. So you can create a synchronization task with these folders, and your offices will have fast access to the files that are centrally located. You can also use this to receive files from your partners, for example. So you have several nodes again, or several partners and clients. You can give them the hot folder application for automation, or you can just have them use the Express app or the web, and you can receive files quickly from several locations around the world, or even domestic. Another use case for FileCatalyst Direct is content replication, so mirroring. So imagine you have a primary data sitting on one location, on your remote location somewhere, server far away, and now you want to do a DR replication, disaster recovery replication. So you can hot folder has the ability to replicate or mirror folders anywhere. So the nice part is you can mirror your folder from the hot folder to the server, or server to hot folder, but as well there is an option where you can replicate your hot folders from one hot folder to another hot folder, bypassing the server. That means the server doesn't need to store the data. It's just used as a pass-through to go from one hot folder to another. So you have the ability to mirror the data in several places with one tool. For those that are in media, we have ability to transfer growing files. So a growing file, imagine you have a large video file that is being recorded to your storage or to your disk, and then you want to transfer that growing file as soon as it hits your disk. You don't want to. It's basically near life situation where the file is being stored and we're moving it as it's growing onto the disk. So here's a workflow that a lot of our clients, especially in live TV production, use for remote editing. So instead of sending an entire edit suite to the venue, you can send, FileCatalyst hot folder with some storage and some ingest tool to create those MXF files. And you can then move the MXF low-res proxy in real time to your edit suite. Your editor is going to be working on the proxy, and then the editor can request the clips that are high resolution. And once again, your ingest mechanism can then conform to these clips and send you high-res back. So like this, you don't need to have, several gigabits of speed at your venue. You can do it with much slower speeds because you're always working on lower res proxies, maybe a 2 megabit proxy, and only the high res stuff is coming later. But this allows you to create, highlights, for example, for a sporting event in almost real time. We have clients doing this, for example, in sports, where in Super Bowl, for example, the highlights from first quarter of the Super Bowl were ready before the first quarter was even done on the air. So this is the type of stuff you can do without sending all editors and edit suites. So once again, growing files is a concept used a lot in the media space, but it can also apply to a regular IT world where you have, large PST files, for example, you want to transfer. You don't want to transfer the PST file every time. You can just want to do it. You want to just synchronize it and send it once. The change of the files. So FileCatalyst Workflow is another product. I'm not going to be showing you the demo of this today, but this is it's a web-based tool that allows you to either do a submission of files via the web, sending files to an email address. So you just send the download link to the recipient, or creating web accessible folders, sort of like an online corporate Dropbox where you can just share files via the web with other users. So workflow is, also highly customizable, can look like the rest of your website, and has custom metadata that you can attach to the uploads. And this is the web-based portion, really fully integrated with the acceleration. So you still get the UDP acceleration on the transfers. And finally, our central product, it's really our central management console. So imagine once you deploy several hot folders around the world, and perhaps you have 2 servers, one on your main site, one on your DR site, with the hot folders. Now you want to, at a glance, be able to see your entire system. You can deploy central, and then within one web console, you see everything. The central will also notify you if there's any problems, if there's any failed transfers, if there's, the links go down between certain hot folders. All of this can be fed into via SNMP traps to your network management tools. And it's a tool really for managing your entire system, your entire system of FileCatalyst transfers. So I'll go through a quick demo here. Once again, we provide a free 30-day free trial of our software. You can request it via our website. But here I just wanted to show you some very quick basics. So here's the FileCatalyst server main console. So here are your usernames. You have different users and the paths where these users' data is located. So for example, hot folder here is mapped to this point on my storage. So whenever this hot folder user connects, will be their folder that they'll see on the system. Additionally, we can also create virtual folders. So imagine if I want to have a hot folder user and this user share a common folder, I can create a virtual folder. So virtual folder will allow me to do sharing and creating the virtual folder will allow me to share between the 2 users. So here I have to specify where the path would be to this virtual folder. So let's say I want to be in my backup here. And with this created here, now I can assign this virtual folder to given users or groups. So let's say user hot folder will have read-only access, yet this user here could have full access on the transfers. So I can create these folders, virtual folders for sharing. I can group my virtual folders as well into a grouping. So for example, my marketing department will have their own virtual shared folders, and my R&D or my post-production will have a different set of virtual folders. So I can group these all together and assign them quickly for easy management. Users as well, FileCatalyst server can also work as an FTP server, so you don't need to have a separate FTP because our FileCatalyst is completely FTP compliant. You can also work as an FTPS server for security, and you can also enable SFTP on it. So if you have other other scripts or other devices that only can do SFTP, you can enable this on a FileCatalyst server. You just be able to monitor and see and manage all of this. But of course, if someone is connecting with just a traditional FTP client, there will be no acceleration at that point. But then you at least have full management to be able to see everything and the reporting as well. The security for the FileCatalyst server, it uses SSL, 256-bit encryption, and AES as well. So everything is fully encrypted, and nothing goes on the wire unencrypted if you want to. You have the ability to send out email alerts. So for example, every time a successful transfer happens, you can be notified. Every time a failure occurs, you can also be notified of that as the administrator. And HTTP fallback, this is the ability to fall to HTTP type of transfers when firewalls block UDP or FTP. Once again, there will be no acceleration, but you still get the full management and the full benefit of using, the FileCatalyst tools. You will also be able to, with HTTP, pretty much bypass any kind of firewall restriction, and you'll be able to transfer files regardless of what's happening on the network. Reporting, we can create, create a CSV file or reporting of all the transfers per user, per file name, per bandwidth used. This is created, and system monitor. This is where you get to see everything that is going on, all your connections to FileCatalyst server, and so on. So I'm going to now take my hot folder application here, which is, now I'm going to switch sides here and become the client. So on the client end, the client has to create a site. In this case here, I already created one. It's a local, of course, it's local host because it's my local client. And now I can, once I have the site created, I can now use this site in the tabs afterwards. Also, if I don't want to have any automation with the hot folder, I just want to use it as a connection tool for regular side-by-side transfers, I can just hit connect here. And this will give me an interface similar to FileZilla, where I can now move these are my local files, these are the remote files. You can see here the virtual folder I created, and I can now transfer files just directly from just this interface without really scheduling anything. So that's on the connection. Now I can create a hot folder here. Hot folder, this is going to be the path locally. Once again, this could be UNC paths, this could be local paths, this could be paths to Samba share, whatever you need. This is really where the file is going to either be automatically downloaded to from the server or uploaded to the server, depending on the scheduler that you set up. And the schedule is really your brains of the operation. So if you create the brains, if you create your task, so you have to give it a name, you have to give it which hot folder you want to deal with, select which site you want to go to, and whether you want to do an upload or a download with it. Your scheduling, you can do it, once a day, every second. We also have something called file system events, meaning that we will only transfer if the directory structure changes. For example, you pointed to a directory of 1,000,000 files. We will only do transfers we will only initiate transfers if the file system events from the operating system tell us that something changed. So we're not constantly scanning millions of files. Connection, here's you can do this is something called what we call an aggression. So how much of bandwidth, how aggressively you want us to pursue the bandwidth available. If you set it to 2, we will behave more like TCP. We'll be very friendly. Everything will be working status quo. If you give it a 5, TCP is going to get slower but still work. And if you give it 7 or more, or even a 10, then TCP is going to be very, very slow. But our goal with our congestion control is really still allow other TCP applications to work. It's just the question is how slow you want other TCP applications on that line with this aggression. As I mentioned, there's progressive transfers here. These are the growing files that you can enable. If this is enabled, then we will transfer file even if it's still locked and growing. MD5 checksum. So this MD5 checksum is something very useful for a lot of our clients. It gives you an electronic receipt, delivery receipt, pretty much the same way as you would hope for getting one from a shipping company like UPS or FedEx, where you get a tracking number, and then eventually the tracking number is going to show you that it was shipped and received. And this is the same idea here, but it's all digital. So we will do an MD5 checksum of the file transferred versus the original file. If it passes, then you have an electronic verification and receipt that the file has been delivered. This is important for like service bureaus, for example, where after certain work has been done and files have been delivered, you can raise an invoice. So here you can raise that invoice as soon as that MD5 checksum passes. Enable multi-client. This allows you to transfer several files at the same time, which is even more optimizes your bandwidth. This is very important if you're transferring thousands or millions of files daily. You can do that, and then multiple files will flow through much quicker. Incremental. This is where you can do your deltas. So imagine you have a file that has changes daily, but it's a big file, let's say several gigs, but changes only a little bit every day. Instead of transferring that file daily for backup, you can do a delta on it. So just do an rsync and send only the changes, and the changes will also go via UDP. You have the ability to create a compression and single archive. This is important for transferring, once again, thousands of files, where we can put the files into a chunk of zip information and transfer it, let's say, 1,000 files at a time. So it's much faster for doing, directories with several 100,000 files. You have your rules here. Send smaller files first, the largest files first. Your synchronization options, what to do with the files if they are renamed or deleted at source. You have the ability here to say, exclude all the files that have, let's say, .temp extension. You can create this, and you can also do regex here. Regex expressions are available. And for post tasks, this is where you can decide what to do with the content that has been sent. You can either do nothing to it, move it to a sent folder, delete it. These are some of the options you can do, and enable email notifications. So that's pretty much what I just wanted to show you here today. You can see here the client and the server. I pretty much am done with the webinar here. If you have any questions, please go ahead now and type them in.